Today we are starting the class by solving one example. Write down. Find out the discontinuities and their types. Find out the discontinuity and their types of fx equals box x, where x belongs to R. R means real number system. The function is fx equals box x. We have to find out its discontinuity and their types. Now check, if you check the graph of box x or the definition, what is the definition of box x? Greatest integer less or equal to x. Yes. That means whenever we will get any integral value of x, the answer will be the same integral value, that is the same integer. And if you get any fraction, then you have to consider greatest integer less or equal to x. That means the left integer we have to consider. That means the point of discontinuity or the breaking of the function will be at the integer points. This is why we will check the continuity on the integer points. So considering one integer, suppose r. So for any integer r, how we can write fx equals box x when r less or equal to x less than r plus 1. Then what will be the value of box x? For this range of x, r is any integer. R. Yes, those who couldn't understand, for them R is any integer. That means take R equals 5 suppose. Now I am giving the range 5 less or equal to x less than 5 plus 1, that is 6. That means it is starting with 5 and ending at before 6, that is 5, 5.1, 5.12, 5.5, etc. Then its box x value will obviously be 5, that is R. So this is R. And the next range is R minus 1 less or equal to x less than R. Then what will be the value of box x? What? Yes? What did you say? I couldn't hear you. What will be the value of box x? R minus 1. Yes, because we are starting with R minus 1 and ended before R. That is R minus 1 point something. That is 4.1, 4.5 like this. The answer will be 4. That is R minus 1. Okay. Now we have to check at the breaking point. The continuity at the breaking point. What is the breaking point in that range? From this one and this one. What is the breaking point? From these two range, can you tell me what is the breaking point for the function? That is where the value is changing from something to another something. R, yes, because this is from r minus 1 to r and then from r to r plus 1. So the breaking point is r. That means we have to check the discontinuity of the function at the breaking point, which is x equals r. So start it at x equals r. Find out. Find these two value and tell me what type of discontinuity it has on r. R and left hand limit r minus 1. Yes, this is quite clear from this range. This is when greater than r, that is r, and this is when less than r. So r minus 1. Now tell me what type of discontinuity it has on r. Jump type, because both the left hand limit and right hand limit both exist, but they are unequal. So f has jump type discontinuity at every integer, because we have chosen any arbitrary integer r, that means it has discontinuity, jump type discontinuity at every integer. And find out the value of jump. One, because the plus value minus the minus value, which is equals 1. Now moving to the sequential criteria for continuity. Next topic. Sequential criteria for continuity. It states that f from a to r be a function and c belongs to a intersection a dashed. A dashed means derived set. You don't know what derived set is? Derived set means the set of a limit point of that set. That means C is any point. Either a limit point, maybe a limit point, or may not be a limit point. C be any point over the domain. Then the sequential criteria is saying that f is continuous at x equal to c if and only if for all sequence xn in A tending to C, if this imply the sequence f of xn is also tending to fc. This is the criteria of continuity. And this is in if and only if condition. That means we can use the necessary part and sufficient part also. So the condition is f is continuous at x equal to c if and only if whenever we will get one sequence xn of a which is tending to c, its functional value sequence f of xn will also tend to fc. Okay. Just like the limit, there was that xn tending to c, this will imply f of xn will tending to L. Just replace that L by fc, you will get the criteria for continuity. Now we will use this concept to solve problems. Mostly this theorem or this criteria used to disprove something, because check, there is for all xn tending to c, it is always impossible to find all the sequence can be defined on a set. So we will find one sequence which is tending to c, but its functional value sequence is not tending to fc. Okay, then we can say by this theorem f is not continuous at x equal to c. So basically this sequential criteria we use it to disprove something. That means to prove that some function is not continuous at a particular point. Okay. So let's solve few examples. Write down next example. Prove that the function fx equals 1 when x belongs to q and minus 1 when x does not belongs to q. Prove that the function fx equals 1 when x belongs to q and minus 1 when x does not belongs to q is discontinuous at every real. Is discontinuous at every real. So let's prove it. At first, we are considering c be any rational number. Okay. We have to prove that this function is not continuous at every real number. Now, between real number, few numbers are rational and few numbers are irrational. Okay. So at first we will prove that it is discontinuous for rational number, then we will prove it is discontinuous for irrational numbers also. So here we are choosing c be any arbitrary rational number. Then what will be the value of fc? One, yes, because from the definition of the function, it takes the value 1 at rational point and minus 1 at irrational point. So fc will be 1. Now, here we will use density property to solve this problem. Now, can anyone tell me what is the density property of rational numbers? Density property. I just want the statement of density property. Does anyone know it? You have used this property in sequence chapter, yeah. In sequence chapter you might need it. Hmm. Between two rational numbers, then uh, not actually correct, but half of it is correct. Anyone else? The property states that between two rational numbers there are infinitely many rationals as well as irrationals. That means whenever you choose any rational point over real line and choose any interval over it, in that interval, however small you can take the interval, there will be infinitely many rational numbers as well as irrational numbers. Okay, we will use this property to solve this. Now here we have chosen C be any rational number, then FC will be equal to 1. Now we are choosing one interval over C. Suppose this is our C. We are choosing the interval of length 1 by n. That is, here it is C plus 1 by n and it is C minus 1 by n. Then by density property we can claim in that interval there will be infinitely many irrational numbers as well as rational numbers. We are only choosing the irrational numbers. So we can say there are infinitely many irrationals xn. We are naming that irrationals as xn, like x1, x2, x3 and so on, such that modulus of xn minus c is less than 1 by n. Right? We can write this. If you break it, you will get c minus 1 by n less than xn less than c plus 1 by n. That means in that 1 by nth interval of c, there are infinitely many irrationals xn. I'm rejoining within a minute, okay? So stay there, all of you.